not going to reread that paragraph. But the bottom thing that I want to make sure you're aware of, so an equation in the form y equals mx is an example of a linear equation, which we have talked about linear, we've talked about equations, we're just putting it all together. An equation is a linear equation if the graph of all of its solutions is aligned. So that's all we're talking about today. Okay, so looking at this first graph, we're going to start off pretty easy. The number of words y you can type in x minutes can be represented by the equation y equals 55x. What does that 55 mean here? What does that represent? What does it represent, Nora? Say it a little louder. Oh, that was almost louder. Words you can type per minute. Okay, so that means 55 words per minute. That's where that comes from, and that's that proportionality, and that is the rate. So the number of words your friend can type in X minute is modeled by the graph. Which of you can type faster? So let's start by writing an equation for our graph. How can we write an equation for this graph? Based on all the things we've been doing. Eric.
Well, I saw that 3 and 50 line up, so I find the constant of proportionality in that.
Yep.
You can write your equation and number of 50 divided by 2, so y over x is 50, so it's y equals 50.
Yes, he's just putting y over x. He chose this point because the line goes through it. The line, you could also choose this point or this point. Any of those points would work, and that would be 50. So my equation would be y equals 50x. And so if we were going to answer the question, this is my friend. It says, which one of you can type faster? You would say, me. Yes, because this is faster than that. Does that make sense?
But it depends on how big the word is.
How big the what is?
Word.
How big the word is. Well, you use small words, don't you? So it's hard to wrong.
Yeah, I can write more words.
I can write more words.
Yes.
I didn't even pick on Jason that time. I picked on Peaches again. Peaches is Sonny, yeah.
I'm gonna go quick. Wait, that sounds weird. I'm gonna go.
What?
Peach. Sonny bottle.
That's so
Wow.
That's so bad.
For it to be special. Peaches.
Might as well just take a cup away.
Wow.
Seriously.
Alright, can you please write an equation for this graph and be able to answer this question? So go ahead and do that one on your own. Okay, what's our equation for our graph? Good. Yep, here it is right here. It's even over 1, so it is super easy. And the question is, which vehicle is traveling at a greater speed than the train? Yeah, so it's 75 miles per hour, and this one is 65 miles per hour. All right, let's keep on moving on. All right, so this is what you guys kind of had a little bit of trouble with when you took the test last time and you had to write your own equations and then tell if they were proportionate. Okay, so here's where we're going to have to write some of our own equations. So the first one says, to sell t-shirts, you're going to double the price. Write an equation that models this situation. Jeremiah. Yeah, YMX. That would be my question too. Because that's what the thing said earlier. Okay, so let's take this. What does M stand for here? That's our constant of proportionality. So we're replacing that M with our number. So we're going to take this out, and then we're going to plop in our 2. Because that would be double the price, right? If I put a shirt for $10 and I want to double it and multiply by 2, now the shirt's 20. Does that make sense? Okay. All right, now the next one I think is a little tricky the way they're saying it. So a hamburger made with a certain type of beef loses 1/4 of its weight while cooking. So have you ever gone to like McDonald's and ordered a quarter pounder? No. No, well, other than Peaches. No. Okay. So, or if you go to a restaurant and it says you're getting a quarter pounder, or then sometimes even some restaurants serve even bigger burgers than that. Okay. So, okay. Well, if you haven't, do you at least know what I'm talking about? Okay. Thank you. So, as they cook, when they say that it's a quarter pounder, that's before they cook it. So as they cook it and all that yummy grease falls off of it, it doesn't weigh a quarter based on the weight of the uncooked hamburger X. Thoughts on that?
I didn't understand what you said about like.
I know. That's normal people cook their food before they eat it.
No, like I was kind of like going like in and out.
Were you going in and out? Yeah. Yeah.
Yeah, and I
You do that a lot.
Did you say that it weighs less than before you cook it?
Yeah. Yes.
Okay.
Yes.
Hey, so you have to find 1/4 of 1/4.
1/4 of 1/4. Now, I was just giving an example of a real life burger, so we don't have to say that the burger we're starting with is a fourth.
Okay. So you have to find 1/4.
Yes, 1/4 of its weight. Yes, Edith. We don't know its weight. You're right. Eric.
Y equals X equals 1/4.
No, because it's 1/4 of its weight. So, like, let's say I cook a burger that's crazy, like 10 pounds. I don't just subtract off a fourth and make it 9 3/4 of a pound. It's going to lose a fourth of it. Does that make sense?
So is it like
Yes.
Y equals whatever however many pounds it is.
Which would be our X.
So how everything got raised.
Sorry.
I pressed the button. Press. There's no back.
Press that back button.
Press that dude.
No. All right, Eric. Okay, then that would be a fourth of whatever it is. Katie?
So then it's a Y equals 3/4 X.
Ooh. So if 1/4 goes away, how much do you keep?
3/4.
3/4. So Y equals 3/4 X. Because however, sorry, my board's kind of skipping. Because however much weight you have, you're only going to get to keep 3/4 of it for the cooked weight. Does that make sense?
Oh yeah.
We're taking out the 1/4. If 1/4 is what we lose, what do we keep? We keep 3/4 of it. So if I made 10 pounds, I would take 3/4 times 10. That's how much I would get to keep of the meat. It is getting smaller, but it has to get proportionally smaller,
Wait,
right?
so when they cook it, do they add on 1/4 pound so that when it's cooked it weighs?
No, they don't. That's what I was trying to tell you. You just lose it. So if you go order a 1/4 pounder, you're really not getting.
Can
A
you go see
1/4
if
pound.
they're buying with
They are buying.
extra
Yes.
quarter?
Well, sometimes you'll even see at the bottom. They'll say, "What? Have you seen it?"
Pretty stupid.
They say that. They'll say pre-cooked weight. A lot. Some restaurants will put it at the bottom. No, McDonald's maybe not so much.
They're too lazy. I'm all about the money.
All right. Okay. So the graph shows the distance d a train travels in time t at a constant speed r. Write the equation. Now, if I say d equals rt, that is the same thing as y equals mx. There's 3 variables. It's the same form. We can use any variables we want. We could say a equals bc if we wanted. Okay, same thing. Okay, that models the situation. So let's start with letter A. What is the constant speed of this train? What is it? How'd you get that? Yeah, right here. Here's your time in 1 hour. It can go 100. So the speed of this train is 100 miles per hour. Okay? All right, how far will the train travel in 3 hours then? Just 300, right? If it's going 100 every hour in 3 hours, it would go 300. Okay? C, how long will it take the train to travel 200 miles? Samantha. 2 hours. Very good. All right, and then the last one, write an equation in the form. Do you guys know what D equals RT stands for? What does that stand for, Kate? It's exactly what it is. Very good. So distance equals rate times time. What? Rate is the same as speed. Yes, very good. So what would my equation be? Raise your hand and tell me. Raise your hand and tell me. So I want more than just 2 people to think about what you're supposed to do here. Now I have 3 people, 4 people. What about Dylan? Yeah, because your distance equals your rate, which we said was 100 miles per hour, times how long I'm on the train. So if I'm on the train for 3 hours, 3 times 100 is 300. That's what I just did. Is that proportionate? Yeah, then I wrote my equation. All right, I'd like you to go through and answer this. Make sure you understand everything that we went over, and we'll be about done. It looks like you put 60 mites. Okay. Anything that you guys have questions on or don't understand? No. Why is Jeremiah so smart? That would be a longer conversation. Not sure.
Everybody thinks
Okay.
questions.
Duh.
I think that, Catherine.